Okay, today I'm talking about the midterm exam. So our midterm exam is constructed by first example is about the universe, and second one about our natural force and its dispersion relation, and third one is related to particle antiparticle annihilation. So let's see about the first example for our midterm exam. So let's read about that. The wavelength shifts in the light from A star and B star indicate that A star and D star have a recessional speed of the VA called 0 to C and VB called 0.8 C. Assume that the distance between Earth and A star is RA, and the distance between Earth and D star is RB. Let's find RA over RB. So it's related to recessional speed and proportional to the distance between the Earth from some stars. The constant between them is called Hubble constant. So this is recessional speed v equal to Hubble constant and distance between the star and Earth. According to that, the R A equal to VA over H. And same way, RB equal to VB over H. So according to that, RA over RB equal to VA over VB. Then can be 0.2C, 0.8C equal to 1 over 4. So let's see this. RD is rather than 4 times compared with RA. So that's the solution about such kind of problem. And let's go to the second one. So okay, this problem is related to, I think this is a very familiar problem to you. So, plane wave solution of the relativistic wave equation for free particle of mass m are of the form such kind like this: mxi equals c0 exponential 2I kr minus omega t, and omega square equal to c square and k square plus m square and square c whole square over h bar square. K show that the group velocity of a wave packet representing a particle of total energy equal h bar omega is the same as the velocity of a relativistic classical particle having the same total energy. So the group velocity is defined by Vg equal to round omega round wave number k. So according to that, let's see this. Okay, partial derivative of k both sides for the dispersion relation for omega square, then 2 omega square round omega round k This is 2c square a. So this part is about the group velocity. So that Vj equal to c square k omega. So here we should show that group velocity equivalent to the velocity of the relative particle. So according to that, to find such kind of relation, let's multiply h bar top and bottom side. Then d square h bar k h bar omega. Then this is equal to c square and momentum of the particle p and energy of particle. Then this is just free. So the group velocity of a particle is equal to the same to the relativistic particles velocity. Once more, the relativistic particle momentum gamma mv and energy of a relative particle gamma mc square. So c square gamma gamma mm. So this is relative particle velocity. Then let's go to the third one. So let's read about this. Find the frequency of the identical photons in pair annihilation with the emission of two photons. So here the important thing is it emits two photons. Positron plus electron produce two photon denoted by gamma. Assume the head-on collision about the electron positron with the same momenta and velocity v with opposite directions. Use electrons mass me and Lorentz vector gamma 1 over square root 1 minus v square over c square. So let's write about the reaction equation. Positron plus electron equal to 2 gamma. So here I assume that their mass given by me. As you know, the antiparticle, the same mass and same all things are same to each other, but it opposite but it having a opposite electric charge compared with particle. So the total energy such kind of the particle can be written by me c square, and electron also same energy because it having a same velocity opposite direction c square. So its total energy 2 gamma me square, and it produces the photon. So one photon energy given by F frequency, but we having a two photons, so 2 HF. This is final state energy. But before we calculating full kind of the all kind of the calculation, but before that, let's just demonstrate about such kind of the situation. So positron head-on collision to electron, and their speed same and opposite direction. So their initial momentum, sum of the momentum is zero, but energy is still plus. But there can be produced a photon, two photons. So there is uh, there is just one way to photon that produce. Opposite direction creation, but their speed same to each other, like speed of light and opposite direction. So to make their momentum to be zero in final state, then their frequency should be same to each other. So according to that, can find that 2HF equal to 2 gamma me c square. This show that F equal to me c square h root 1 minus c square. So this is a frequency about the produced okay, I think our midterm exam not difficult, but I think some parts of the maybe little bit weird to not familiar with to you, but anyway, I think you yeah very well. Okay, let's go in on our study about next chapters. So okay, number of chapter 3.12. So now we study about the Einstein coefficients. So we already study about the Planck's law, Planck's way about to study about the black body radiation. But the same era, the Einstein also study about the and also concern about the black body radiation because it is related to photon, multi-photon system. So Einstein some very simple but important thing concept about the black body radiation and related to quantum field theory. But in this case, he just consider about some kind of the quantum system. So let's see this 3.2 Einstein coefficients. Main coefficients. Here, Einstein consider black body radiation a kind of equilibrium state. But if we apply about the quantum theory, the black body radiation, we don't need to equilibrium. But anyway, Einstein, Planck consider black body radiation a kind of the equilibrium state. So here, still the black body radiation is equilibrium. So let's consider a two-state system, very simplified the black body radiation. So the upper one, okay, there are two energy states. One is a E2, the other one E2. So this is a kind of the state. So there are many status atoms can be lie. So there are some states and state for atom and state and state. Well, the same way, this is low state for atom, low state for atom, low state for atom. Okay. Then when atom transit to some transition in their energy state from 1 to 2 or from 2 to 1, then the energy difference can be produced the photons corresponding to difference between energy states. So difference between the energy state, the energy of a photon. And number of photons, number of atoms are in the state. This is N1, this is N2. Atoms are there. Then atoms can be go. Then the photons can be produced in this case. Or atoms can move state go up. Then kind of photon should be absorbed to the atom, to the lower state. So there are so many atoms and so many photons in black body. So the change between the states very many times in very short times. So let's consider number of n2 change to n2 n2. But such kind of the change very frequently occur in black body. But in this case, we consider the possible change, the reason of the such kind of the change. We can consider two reasons. So we divide the two cases. One is spontaneous emission. And second one, just stimulated emission. The spontaneous emission the atom, the state E2 goes to E1. Just spontaneously emit photons. So this is a spontaneous emission and occur very right way. So we define coefficient, such kind of the emission related to the possibility coefficient A. So spontaneous emission defined by coefficient A. And the second one, but the stimulated emission. So stimulated emission is related to stimulated atom via free photons. So let's see this. There are still two energy states and atom in one. Atom is at the E2 state, so higher energy state, but there are so many photons in the black body. So some going photons stimulated atoms at the E2. Then atom at the E2 move to E1 because some photons hit the atoms at the E2. Then in this process, the still atom emit one photons. Chiba omega. So such kind of the stimulated emission can be frequently occur when the intensity of the photon in black body larger and larger. So the possibility such kind of the stimulated emission related to coefficient B and intensity of black body giving a omega function of the omega. Because the intensity proportional to number of photons. So spontaneous emission proportional to the number of the photon at the state E2 and stimulated emission also proportional to the N2, but it is also proportional to B I omega. So the change in number of atoms in the E2 can be written by change in N2 equal to minus A plus B I omega N2. Minus means the atoms at the E2 move to E1. So number of atoms will be smaller than before. So this is a stimulated emission and spontaneous emission. Consider both sides. Then you maybe some so that there are some particles go to the from E1 to E2. Then that is will be related to plus part. But this plus part is related to uh, related to atoms at the E1 goes to E2 after some observed with the photons. So the fully write down about the plus part, we need to consider about the how many particles move to E1 from E1 to E2. We also consider that E1 and 1 change to N1 GN1. But in this case, there are no spontaneous emission because this is an E1 is a lowest state in this system, so it cannot be emit some photons. It just absorb photons, so it is just related to stimulated emission. So these atoms observed around the photon, then it goes up to E2. So there are many photons around E1. Then it observes some photons. Then goes to higher photons. So such kind of the probability atoms move to E1 from E2. Coefficient E prime I omega. And then, okay, we can write down here. So such kind of a relation or probability, number of particle move to E1 to E2, E I omega N1. Because if there are many particles at the E1 state, then there are much more probability particle move to E2. So now we consider equilibrium state. The change to E1 from E1 E2 and from E2 to E1 same to each other. Then the system will be equilibrium. So according to that, again, change in N2 equal to minus change in N1. And this can be written by A plus EI omega N2 plus E prime I omega N1. For the addition to that kind of the assumption, Einstein also assumed that the molecules or atoms are also equilibrium. This implies that N1 equal N2 both will be zero. So the such kind of the change right way equilibrium to each other. And Then we impose about the Boltzmann distribution, about the number of particles. So we consider Boltzmann distribution. Then N1 equal to total number of the particle E2 minus beta E1, and N2 total number of particle N E2 minus beta E2. Then insert such kind of whole thing minus A plus B I omega N minus beta E2 plus E prime I omega N minus beta E1 equal to 0. So this can be simplified to that minus A exponential minus beta E2 plus E prime beta E1 E2 minus beta 2. So the intensity, such kind of the black body radiation, we consider black body radiation in some system. Then there is intensity defined by I omega, and you find that P prime E1 P minus beta E2 over A exponential minus beta E2. So this quite quick simplify to that prime to let's multiply exponential beta E2. Then you find that beta H bar omega. I define the H bar omega equal to E2 minus E1 minus B and A. But we already know that for equilibrium, the flat body relation I omega equal H bar over pi square omega 3 square exponential H bar beta omega minus 1. So compare with our previous and this result. Therefore, E prime equal to B and A over B equal to beta over pi square and omega 3 square. There are some physical meaning such kind of the relation. B prime the related to stimulated emission. So absorption and emission may be the same to each other. This implies that emission equal to absorption. But we still unknown about the A over B, but this will be determined by quantum mechanics. So, without Einstein coefficient, we can explain about the black body radiation intensity. Also, without equilibrium. Quantum field theory. To understand about the black body radiation, all details things. So, I will talking about the quantum field theory basics at the next time. See you then.